Welcome. In this video, we will discuss the idea of continuous income streams. So let's start by considering a definition, and then we'll work through a few examples. So suppose money can earn interest at an annual interest rate of R, compounded continuously. We'll let f of t be a continuous income function in dollars per year that applies between year 0 and year capital T. Then the present value of that income stream is given by PV is equal to the integral from 0 to capital T of capital F of t times e raised to the negative RT dt. So let's just discuss this expression again. This is taking a continuous income stream or a continuous payments of some sort with an interest rate of R, and it's considering the present value of that income stream. So this is discussing what's the present value of money that is going to be earned or accrued over time from now until T years from now, capital T years from now. This can be a helpful tool. This present value of money can be a helpful tool when comparing two different investments, or whether or not to purchase a business for a certain dollar amount today, when you know the projected growth of that business and the income that business will give you. So we'll take a look at a couple items. One is going to be a business purchase, and then the second one will be doing a comparison between two payouts or investments. It'll be through the lottery, but it'll be the same idea as two long-term investments. So let's start with this first example, and we'll read that together first. So you have an opportunity to buy a business that will earn $75,000 per year continuously over the next 8 years. Money can earn 2.8% per year, compounded continuously. Is this business worth its purchase price of $630,000? Okay, so let's go ahead and consider what elements here we're working with to fill in this present value expression. So looks like we have a income here, this business that will earn $75,000 per year. This value is our continuous income stream. It just happens to be constant. It's constant at $75,000 per year. And so this is our capital F of t function. Again, it doesn't matter what year we're in, we're still going to accrue $750,000 in income each year. It says that we can have this income stream for the next 8 years. This 8 years is representing that capital T value. So we're going to be able to accrue this interest or this income here from year 0 to year T, capital T is equal to 8. The interest rate, I think pretty clearly, would be our R, our interest rate R. And when we represent R here, we want to make sure that R is represented as a decimal. So we'll use that R as 0.028 or 2.8%. So that is used here. And then we know we want to compare what is this present value of this business to the purchase price of that business, which is $630,000. So if we go through this process and consider the present value of this income stream, what it would be worth today, and compare it to $630,000, we want to make sure that the present value of the business is more than the actual asking price for the business or the purchase price. So let's go ahead and consider that. Let's set up the present value of that income stream. We would say that PV, the present value, is equal to the integral from 0 to capital T, which is 8, our f of t is just constant at 75,000. And we'll have our interest, so e raised to the negative 0.028 times little t dt. Now, this is kind of, that negative there, again, is kind of saying we want to pull back all that interest kind of in reverse and consider, again, what sum of money right now really invested would be equivalent to the income that the business would receive. So this present value when we're done is really the equivalent sum of money that I could have today and invest at that same interest rate to have the same amount at the end of this 8 years as the business would have. So let's go ahead and evaluate our integral here. This is an exponential integral. So when we consider the antiderivative for our exponentials here, we know we're going to rewrite our exponential. And since this is a linear function up in our exponential, we can kind of see how we can do this without u substitution here. Let's take that antiderivative. We would leave the 75,000 as a constant. We could rewrite our integral. And then instead of multiplying by the derivative of the exponent, we want to, again here, divide by the derivative of the exponent. In this case, this will work because, again, this is a linear function in my exponential. So we could say that this is negative 0.028, divide by that. When I take that antiderivative, and we'd like to evaluate this antiderivative from 8 to 0. Again, you can double check that this antiderivative is correct by considering taking its derivative. When we take the derivative, everything will remain, except we'll have to multiply by negative 0.028 when we apply that chain rule. So when we go to evaluate this at 8 and 0, we can write that out here as well. 75,000 divided by our 0.028, and then raise e to my rate times 8. And then notice that if I evaluate the expression at 0, we'll have our same value, 75,000, divided by negative 0.028, and then e really raised to the 0 power if t is equal to 0 there. Now, e to the 0 is 1. And so when we go to put this into our calculator, this value here is just going to be 1 times that fraction right here. So if we go ahead and evaluate this in our calculator, let's go ahead and get an approximate dollar amount here. This present value of the business, again, what that business is worth today, is equivalent to $537,548.75. Now, let's go ahead and compare this with what they are asking for the business. So the seller is asking $630,000 for this business. But notice that we have shown that the present value of the business is only worth $537,000. So would we recommend to someone to buy that business, or would we buy that or purchase that business ourselves? Well, I don't think we would, because we know that the income stream does not profit us enough to make that purchase price worth it. So in this case, we could say that we do not want to buy this business. So this business is not worth the purchase price. Of $630,000. It's not worth that. So again, we would not purchase that business based on the income that that could produce. Let's go ahead and take a look at a second type of an example where we're going to consider two income streams. It'll work mathematically the same, but it'll have a little bit of a different context. So the second example says, assume you won the lottery. That's a great assumption to make, but let's assume that. And are offered two options. You can take $11 million today and do whatever you want with it, or you can get paid $1 million a year for the next 20 years. Now, whatever you want with it, let's just assume that you go ahead and responsibly invest this $11 million, the same you would invest your $1 million payments here. So let's assume you make 7% interest on investment, on any investment you make over the next 20 years. Is it better for you to take the money up front, so that was the $11 million, or take the 20 years of payout? So the $1 million payouts each of the next 20 years. So let's just break down our two options. So option number one is you get $11 million today. Okay. Option number two is we get $1 million. So $1 million for the next 20 years. So in total, this lottery will pay us out $20 million over the course of those 20 years, or they could give us a lump sum of $11 million. Okay, so those are our options. We want to again consider, well, what's the present value of each of those investments? Well, let's start with the option number one. Well, the present value of that lump sum is exactly that lump sum. So here, the present value of this investment would just be $11 million, because that's how much I have today. It's just the $11 million. Now, the question is, what's the present value of this income stream in option number two? Well, that one's a little more difficult. We're going to have to work out what the present value of the income stream of $1 million is for the next 20 years. Therefore, we could say that the income stream, that capital F of T, is equal to just 1 million. So that's 1 million. The capital T, how long are we going to get that investment or that income stream, is for 20 years. And we know, again, that we're going to get 7% interest on our money. So we can say that R is 0.07. So we can take that 7% interest for the next 20 years. And again, I think that would be pretty reasonable if we invested in mutual funds or stocks in the long haul. So let's go ahead and set up our present value equation. So this would be the present value of my integral from 0 to 20 of, we could say, well, for $1 million is our income stream, and we'll just do this in millions of dollars for ease of use here. And we want to multiply that by e raised to the rate negative 0.07 times t dt. That's our expression. Now again, let's go ahead and take our antiderivative of this exponential. We can say we're going to rewrite my exponential And then in this case, we can just divide by the derivative of the exponent, again, since that is linear, so negative 0.07. And we're evaluating here from 20 to 0, or 0 to 20. We'll go ahead and jot this out. We have e raised to the negative 0.07 times 20 divided by negative 0.07. And then we'll subtract, if this is e raised to the 0 over negative 0.07, we can offer this is going to be really a positive value here when this is done. And again, this goes to 1. So if we go ahead and evaluate this expression in our calculator, we'll go ahead and find that present value of the investment to be 10.763, and then that's in millions of dollars. So that would be millions of dollars. So this tells me that the present value of the income stream of $1 million a year for 20 years is equivalent to investing $10.763 million today. So what should we conclude? Well, it's pretty clear here that $11 million presently, with the present value there, is greater than the present value of my income stream. So which should I choose? Well, this would tell me to choose the lump sum and then invest my lump sum at that 7% for the next 20 years. And by the end of that 20-year period, I'm going to have more than the income stream in option number 2. So this would tell me again, you should choose the $11 million, excuse me, the $11 million upfront, or the lump sum, and invest it at 7% interest. If you do so, you'll have more money at the end than investing at 7% of $1 million for the next 20 years. So choose option number 1 here. That will give you the most money at the end of 20 years. So again, if we change some of the components in this question, the answer might be different. It's not always going to be choose the lump sum. It's all based on the relationship between the interest that we get and how long we get those installment payments. So in this case, we would say choose the lump sum. So thanks for watching this video with continuous income streams. We will be back with another video soon that will go through our last section in the course. So thanks for watching. I'll see you in the next video.